Okay, we're back, and we were just about to start with unit conversions under the heading Solving Chemical Problems. Unit conversions are a really important thing to be able to do because of what I was saying about, well, for one thing, a lot of measurements that we're familiar with being in English units, whereas science is done almost entirely nowadays in metric units, and also the fact that there are certain default units that you have to use in the SI system if you're going to put numbers into an equation, like the kinetic energy equation or something like that requires the numbers you put in to be in certain units. Those units are not necessarily the units that you would use when you're making those measurements because the official SI units are not always convenient to use. So we need to be able to know how to do unit conversions so that we can get from the units we actually use to the units we need. So the goal in unit conversions is to convert some quantity or measurement from one unit to another. And you want to be sure that you're not changing the value of the number that you're converting. You really just want to change the way that you express it. Okay, so this is, for example, a very simple example, changing from inches to feet or feet to inches, or changing from centimeters to kilometers, or something like that. And unit conversions are also known as dimensional analysis. It's important to keep, it's called dimensional analysis in part because you're watching the units. The fact is, if you set it up so that the units come out correctly, the number probably will be correct also. And remember that units multiply and divide just like numbers. So for example, a measurement in meters times another measurement in meters would give you an answer in units of meters squared. But when you add and subtract units, the numbers that you're adding and subtracting have to be in the same units, and the answer comes out to be in those same units. So a measurement in meters plus another measurement in meters will give you an answer in meters. So that's something to keep in mind. An example of a unit conversion, a very simple one, would be a very pretty simple, straightforward example to sort of show us the principles of how these things are done would be to take something pretty obvious like 18 inches and convert to feet. Well, we already know 18 inches is 1.5 feet. But just to see how the principle works, we can take 18 inches, and the way these usually work is that you take the number that you're given, you multiply it by a conversion factor that's based on some equivalence statement. And in this case, we have the fact that there's 1 foot for every 12 inches. And that gives us an answer in feet. Now, if you're watching the units, and it might help if you think of any number that exists just by itself as being that number over 1, because that can make it easier to keep track of what's in the numerator and what's in the denominator. And you'll notice here that you have inches in the numerator and inches in the denominator. Well, like I said, units multiply and divide just like numbers do. If you have a number divided by itself, it cancels out and basically becomes 1. So the same is true of units. If you have inches divided by inches, that cancels out and becomes 1. So those units essentially disappear. The only units left would be feet, and those indeed are the units of the answer. For the number then, once you work out the units, all you have to do is multiply the numerators and divide by the denominators. So in this case, it's 18 times 1 divided by parenthesis 1 times 12, close parenthesis, and you get your answer. Now in this case, you don't actually have to do anything with the ones because they're not going to change the value of anything. So essentially all we're really doing here is taking 18 divided by 12. And so when you do that, you get 1.5. And actually it's 1.50 because of significant figures. Notice that's the significant figures. You've got 3 significant figures in 18.0. That 0 counts because there's a decimal point, so that's 3 significant figures. And the 1 over 12, that is a definition within the English system. And so both of these numbers, the 1 and the 12, would be considered infinite insignificant figures. So 3 would be the fewest number of significant figures, and that's what your answer should have, 3 significant figures. Also, when we're setting this up, this is the conversion factor. And the conversion factor comes from the equivalence statement, which is 1 foot is equal to 12 inches. And when you turn an equivalence statement into a conversion factor, you basically take it and turn it into a ratio. And you can turn it into a ratio either way, depending on which way you need the units to be in order to make the equation come out the way you want it to, to get the units you want for the answer. So you could use this conversion factor as 1 foot over 12 inches, or you could use it as 12 inches over 1 foot. And you can do it either way because in principle, either of those ratios is equal to 1. Okay, so you can use it either way. There's 1 foot for every 12 inches, but there's also 12 inches for every 1 foot. And like I said, you can use these in an equation without changing the magnitude of what it is you're measuring, because in principle, both of these ratios are equal to 1. 1 foot and 12 inches are the same thing. It's not numerically equal to 1 because you're measuring that distance in 2 different types of units, but in principle, it's equal to 1, like I said, because they're the same thing. This is equal to 1 also because 12 inches and 1 foot are the same thing. Which one you use will depend on which units you start out with and which units you end up with. Normally, you want the units you start out with to cancel out, so you would want those units on the bottom. In this case, that's inches. And you would want the new units that you want to end up with on top because that's where you want the new units. So that's why we used this version of the conversion factor in the equation instead of this one. It's because this one canceled out inches and left us with feet, and that's what we wanted to do. Okay. The general form for unit conversions takes the form of the measurement involving units that's given, a conversion factor, which normally involves the units wanted over units given, and if you look at how the units cancel out, you can consider units given to be over 1, so that makes units given in the numerator, which means units given will cancel with units given in the denominator of the conversion factor, leaving you with the units wanted. And that is the general form for any conversion factor. And that's exactly what we did up here. Inches were the units given, and you always keep the number that goes with those units with the units. So inches were the number units given. We use the conversion factor in the form of units wanted over units given, feet over inches, and that leaves us with the units that we want. And that's the way that we normally do conversions. People don't like to do this, but it is very important to watch the units. Because that can help guard against using the wrong conversion factor. Or using the correct conversion factor, but using it upside down. Okay. So for example, up above, if we use that conversion factor upside down, and we took 18 inches times 12 inches over 1 foot, what would this be equal to? Well, it's 216, but the units would be inches times inches over feet. That's square inches per foot. And see, the units make no sense. And so that's a pretty good indication that you did something wrong. So you try it with the conversion factor the other way around, and lo and behold, you get feet. And that's exactly what you wanted. So you always want to use the, basically you always want to keep track of the units. The book uses a conceptual plan for problem solving, which has to do with mapping out your route from the information that you're given to your conclusion. I'll summarize what the book does. You really need to kind of read it in detail yourself to get the gist of it. But anyway, what you want to do is to assess the information given, and devise a way to get to the final destination. So you'll have a starting point, that is where you have the information that's given to you in a question. And you will have a conceptual plan. That will get you from that will get you to the ending point. And you want this to involve information that you can either know or you can look up, and eventually you want that to get you to the ending point. And there are 4 steps that can help you with this. First step is to sort the information given and find what's needed for an answer. The second thing is to strategize. Okay, strategize. That means basically develop a plan. And that usually involves some sort of conversion factor or an equation, or maybe both. One thing you might want to try is sometimes it helps if you work backwards. Start with the units that you want for the answer and think, okay, how would I get from there back to where we're starting? If you're converting between the English and metric systems, it helps if you first find a conversion factor for crossing over from one system to the other with that type of unit. So an example might be say, if you wanted to convert kilometers to feet, a certain number of kilometers to feet. Well, you might not know what to do at first, but just think of what type of measurement these are. These are length units. And so see if you can find a conversion factor between the English and metric systems involving length. The fact is that unit conversions can be done in practically an infinite number of ways. There's usually no one right way to do a unit conversion. And some ways may involve more steps than others, but we generally, I mean, unless you get really ridiculous, we generally don't deduct points for using more steps than absolutely necessary. So, in this case, going from kilometers to feet, what we need as a potential first step is find a conversion factor between the English and metric systems in units of length. One that I can think of off the top of my head is the fact that 1 inch is equal to 2.54 centimeters. So that gives you kind of a midpoint to shoot for. So this means that you have to go from kilometers and you somehow have to get to centimeters. But once you're in centimeters, you can get to inches, and getting from inches to feet, that's really easy. So this has sort of filled in a lot of the blanks in how to get from from the beginning to the end. All you need to know now is how to get from kilometers to centimeters. In the metric system, when going from a unit with a prefix like kilometers to another unit with a prefix like centimeters, I think it's probably a good first step anyway, to stop off at the base unit. In this case, that would be meters. So if you go from kilometers to meters, then you can go to centimeters, and all you have to do for these two conversions is know what the metric prefixes mean. Kilo is 1,000, so a meter is 1/1000th of a kilometer. There are 100 centimeters in a meter, so now you can go to centimeters. Once you're in centimeters, you can use this to go to inches, and then everybody knows, hopefully, that there are 12 inches in a foot. So now you've gotten to feet. So this is one way to do it. It's not the only way to do it, and there are ways that would involve fewer steps. But you know, this is the kind of thing that you can do to solve these problems. And this is what I was saying about metric units with prefixes. That when you're going from one metric unit with a prefix to another metric unit with a prefix, it's always safest to stop off first at the base unit. And we saw that in the last example. If you want to convert from kilometers to centimeters, the best thing to do is go from kilometers to meters and go from meters to centimeters. That helps avoid mistakes in trying to combine two factors of 10 at once to go directly from kilometers to centimeters. Again, to go from kilometers to meters, all you have to do is know what the meaning of kilo is. And to go from meters to centimeters, all you have to do is know what the meaning of centi is. And that's pretty easy. Okay, so that is that step. 3 is solve it. That essentially means work out the math. And pay attention to the units. One hint in watching the units is that if the units get bigger, the number should get smaller. Because again, you're trying in fact not to change the magnitude of the quantity that you're measuring. You're trying to express it in a different way. And so if you're measuring with bigger units, you better have less of them. If you think about the relationship between inches and feet, 12 inches is the same as 1 foot. So if you've got 1 foot, a foot is a big unit, and you've got one of them. If you're converting that to inches, well, you get 12 of them. Inches are a smaller unit, so you'll have a bigger number of them. It takes more of those smaller units to equal one of the bigger units. And it works the other way around too. If the unit gets smaller, the number should get bigger. The 4th step, if possible, is to check your answer. So for instance, does the answer make sense? Do the units work out? If the units don't add up, basically, so if the units work out correctly, then the number will probably work out correctly too. Okay, some examples of unit conversions. We can do a few. So suppose you want to convert 288 centimeters to yards. Okay, this a lot of conversions will end up requiring more than one step. And like I said, for most unit conversions, there are any number of different ways that you can do them, practically an infinite number of ways. Okay, so let's see. One route might be to go from centimeters to inches to yards. Okay, so the first method could be to go from centimeters to inches to yards. The second method could be to go from centimeters to meters to yards. And there are, like I said, there are any number of other ways to do it. Hypothetically, any unit conversion can be done in one single step if you know the right conversion factor. But doing everything in one step would require you to have access to literally thousands and thousands of conversion factors. And they're probably out there somewhere, but it's really a lot easier, even in this day and age with Google at your beck and call, to know a bunch of conversion factors and then basically, but not thousands of them, and then just resign yourself to using more than one step for a lot of conversions. So going from centimeters to inches to yards, we can take 288 centimeters, and there's 1 inch for every 2.54 centimeters. And that gives us, I'm running out of room here. 113.358268 inches. Now I'm leaving in a ridiculous number of significant figures in this calculation because we're not done yet. This is what I meant when I said you don't have to round off a number until the final step of a multi-stage calculation. We're not done yet. So you may not want to keep all of those significant figures, but you can look at the numbers that we're putting in here. That number is 3 significant figures. That number is 3 significant figures. And so it's a pretty good bet that you're going to be limited to 3 significant figures for your answer. So you might want to use 4 or 5 significant figures for this intermediate answer and get rid of the rest of them. But I'm going to keep them all. So then we need a second step where we take the answer from the first step, 113.385828 inches, and multiply it by our next conversion factor. We've got inches. There's 1 yard for every 36 inches. And that gives us our answer. And the answer we get is 3.149606299. And that would be in units of yards. But, of course, now we have to cut down for significant figures. We had 3 significant figures in this number, 3 significant figures in the 2.54 also. Now, looking at this 1 yard for 36 inches, you might be tempted to call that 2 significant figures. But remember, this is a conversion factor within the English system of units. Those numbers are exact. So the 1 and the 36 are both considered infinite in significant figures. So that means 3 significant figures it is. 3 significant figures. Okay, so that means the 3 and the 1 can stay. The next digit can stay also, but before we write it down, you want to look at the first digit you're dropping. That's a 9. 9 is greater than 5. That means the last digit you're keeping has to go up by 1. So it's 3.15 yards. And that is your answer in the proper number of significant figures. The other method would be to go from centimeters to meters to yards. For that one, we've got 288 centimeters. Okay, there's 1 meter for every 100 centimeters. And that gives us 2.88 meters. 2.88 meters. And if you look up the conversion factors between yards and meters, there's 1.094 yards for every 1 meter. And you multiply that out, you get 3.15072 yards. But like before, you're limited to 3 significant figures. And so it becomes 3.15 yards. You're limited to 3 significant figures in this calculation because the number you started out with was 3 significant figures. 1 meter for every 100 centimeters is a definition, and that is considered infinite. 1.094 is between the English and metric systems. So that number is rounded off. It is not infinite, but it is 1, 2, 3, 4 significant figures. So 3 is the limiting number. So 3.15 it is, which is exactly the same as what we got over here with the other method. Okay. There are also problems that involve compound units. Compound units are units that are made up of 2 or more other simple units. And I am going to stop this part of the lecture right at the moment. And we'll continue after this with the rest of this.